In this question, an object of mass 10 kilograms is being dragged across a rough horizontal surface. Working on my diagram, what do I have? There is the surface, and I'm going to draw my object as a point. We've been told that object has a mass of 10 kilograms, so its weight is operating downwards. Weight equals mass times gravity. The mass is 10, so 10g. There is a normal reaction operating then, upwards and in the opposite direction. We're told the coefficient of friction is 0.3 and the acceleration of the object is 3. Now we're being told that it's being dragged across. So if you imagine someone tying a rope to it and pulling it across, or if it was a box, someone bending down and pulling the box across the surface, that dragging force I'm showing as D. We know there is friction involved because we're told this is a rough surface, and we know that friction is equal to mu times n and operates in the opposite direction to motion. So if I'm being dragged towards the right, that means my friction is operating towards the left. And because we know friction is equal to the coefficient of friction, mu, times n, the normal reaction, and we are told the coefficient of friction is 0.3, we get 0.3n. That must be operating in the opposite direction to the dragging force. I have drawn in unit vectors I and j. So here we go. We want to work out the dragging force that is parallel to the surface. That is, we want to find D. We know that if we're going to look at what we have here, we have Newton's second law, R equals mass times acceleration. We know that the acceleration is going to have to be horizontal. It's in the direction of movement. So I know vector A equals the magnitude of vector A, its acceleration, times I. And we know that acceleration is 3. We're told that in the question. 3I. I also know that the motion is horizontal, and because the object is not lifting off the surface, we know the normal reaction must equal 10g, so they're in balance, which means D minus 0.3 is our resultant force. We know that the mass was equal to 10, and we know the acceleration was equal to 3. We do not need to write the i's in there. So, rearranging this, we have 10 times 3 is 30. But I have 0.3 times n. Now, we know 10g is equal to 10 times 9.8, which is 98. So we know n is equal to 98, which gives me D equals 59.4, and I'm using n for newtons. In the second part of the question, it becomes a little bit more complicated. The dragging force is at an angle. It is an angle to the surface, and that angle we have called theta. We are told that sine theta is equal to 4/5. Looking at that, what we can recognize is that is opposite side over hypotenuse. So if we were to draw a right-angled triangle, we know the hypotenuse will be 5. We know the opposite side will be 4, which means we can recognize the adjacent side would be 3. So if we know sine theta is 4/5, cosine theta will be the adjacent side over the hypotenuse, which is 3/5. We know we have a surface. We know that we have the object with its weight operating downwards. Weight is mass times gravity, so 10g. That has not changed. We also know we have the normal reaction operating upwards. We know that the object is being dragged along the surface. So we know it's moving along the surface, so we still know that friction operates in the opposite direction, and that is 0.3 n. That hasn't changed. What has changed, though, is the dragging force. The dragging force is D. So, we do know, though, that that makes an angle of theta with the surface. If you look at what we have here, we have a right-angled triangle. We know that this side here is D, this angle here is theta. We know that this side is the opposite side, and this side is the adjacent side. If I was going to work out the sine of theta, what I would have would be the opposite side over D, which means that the opposite side is equal to D sine theta. And we know sine theta is 4/5. That will come out to be 4/5 D. We also know the adjacent side is D cos theta, using a similar process, which will be 3/5 D. We know we can look at all the resultant forces operating on this point, this object. I'm going to resolve D. What we have going horizontally is going to be 3/5 D, or you could say at this point D cos theta. Now, because I'm resolving vector D, if this is D cos theta horizontally, vertically is D sine theta, hypotenuse is D. If I'm going to resolve this, I have operating upwards D sine theta. But I'm not going to write that there. I'm going to take that vector and I'm going to move that across so that it is along the axis. was going to draw this now on my previous example, so how do we go about solving this question? The first thing I'm going to do is look at the resultant forces. The resultant forces I'm representing as vector R. Firstly, we have the forces operating horizontally. We have 0.3n in the I direction, and because we have resolved vector, we have d cos theta also in the I direction. Now d cos theta is in the positive direction, 0.3n is in the negative direction, so I've got d cos theta minus 0.3n in the I direction. Now I'm going to consider the vertical direction. In the vertical direction, there are three paths. Going down, so negative 10g. We have the normal reaction going upwards, so positive n. And because we resolve vector d, we have the d sine theta also going upwards. So the two positive bits going upwards are n plus d sine theta minus the part going downwards, which is 10j. So what I've got is my resultant vector is d cos theta minus 0.3n in the I direction plus n plus d sine theta minus 10g in the j direction. We know R equals ma, so that is equal to mass times acceleration, and we know the movement is in the I direction because acceleration is in the direction of movement. Okay, so what are we now going to do? We know the mass is 10, we know the acceleration is 3, 10 times 3 is 30. Hey there. What we actually have is 30i plus 0j. So what I can say is, by equating the two components on either side of the equal sign, I know that d cos theta minus 0.3n is equal to 30. That is my first equation. From what I did earlier on, I know cos theta is equal to 3/5, so we know we're going to get 3/5 d minus 0.3n equals 30. This is one equation. Next thing I know is I have n plus d sine theta minus 10g in the j direction. Now, there is no movement up or down, so I've got 0j, so that will equal 0. So I've got n plus d sine theta minus 10g equals 0. I know again from my earlier working, sine theta is equal to 4/5, which means that I know 4/5 d is equal to d times sine theta. So I have n plus 4/5 d equals 10g. I got the 10g by adding 10g to both sides. I now have two simultaneous equations, and I can then solve for n and d. Remember, g is 9.8. So my final answer is d equals 70.71 newtons, and The normal reaction is 41.42 newtons.